The content from this video is found from videos on the Electrical Code Coach's YouTube channel. Be sure to check out his channel as well as his videos. This will be a remake on the information found in his videos. I'll do my best to include everything that he did in his videos, as well as try to explain some things that I think might need some explaining. So be sure to check out his original videos on the same topics. The link will be in the description. Welcome to this video about conduit fill, otherwise known as pipe fill. This could be looked at as a sequel to my sizing conduit video, as that video is going to share some helpful information that will make things in this video more familiar. You're going to want your National Electrical Codebook for this. I'm going to be using the 2020 version, but this applies to 2017, 2020, as well as 2023. There weren't any changes. We're going to want to be in chapter 9 of the codebook, specifically tables 4 and tables 5. We're going to use table 5 to find out the size of the wire in square inches. That's going to come in handy. Then we're going to use table 4 to figure out how much we can fill that conduit. This will make more sense as I go along, so I'm just going to get into it. As always, the first question is going to be simple, and in this case, it could serve as sort of an intro question, where the next question is going to build off of this. And this is going to be the first half. Okay, so first off, how many number 12 THHN fit in a 3/4 inch EMT? Okay, so to do this, I'm first going to figure out the size of my conductor. I'm going to go to table 5. I'm going to look for the THHN number 12. I found THHN, I see number 12, and it is 0.0133 square inches. Then we're going to go to table 4, which is right before this. We're going to find the EMT, and we're going to look at the size for 3/4 inch. So we'll go to trade size, 3/4 inch. We're going to look at over 2 wires because we're going to assume from some knowledge here that we're going to be using more than 2 wires. And this will be in most circumstances. Sometimes this won't be true, but from just actual real life experience and common kind of knowledge, you should know you're going to be able to fit more than 2 wires inside of a 3/4 inch EMT if you're only using number 12 THHN. That gauge is pretty small in actual size compared to other gauges you're going to be working with. Of course, this is pretty obvious, but this goes into the obvious nature of this. So we're using the over 2 wires column. We see 0.213 square inches. We can also glance at the size of the individual wire itself, and then also the size of the conduit that we're working with, and we can obviously see we're going to be using more than 2 wires here. Or should I say we're going to be able to fit more than 2 wires in here. Okay, so we're pulling out the handy dandy calculator, of course. Okay, and if we want to find out how many times this goes into this, what are we going to do? And this might be pretty obvious for you, but if it's not, it will become very obvious when you think of 100 dividing into 50. In other words, how many times does 50 go into 100? Okay, so you see, so if we want to find out how many times 0.013 goes into 0.213. Okay, so we're simply going to get the 0.213 and we're going to divide it by the 0.013. We're going to come up with 16.38. Okay, so it's pretty obvious that we're not going to be using 0.38 of a conductor, but in fact, you have to know one rule. And that is that if you are over 0.8, then you're going to round up. So in this case, we have 16.38, so we're not going to. If let's say we had 16.88, then we would round it up to 17 conductors. Okay, so we can accurately say 16 conductors will fit in a 3/4 inch EMT when we're using number 12 THHN. Now remember that I did that method to teach a lesson. So now we can go to Annex C and double check. We'll go into the EMT column, we'll look at THHN, we'll look at the number 12, and we'll go under 3/4 inch. And we see the number 16. Of course, in real life, you wouldn't do all this work to double check it, but I'm proving to you that this method works, and it's going to be compliant with other resources you're going to find in the codebook, such as Annex C, which is a totally different table, but you have the same answer. Okay, so I just like to be confident that what I'm teaching is going to be correct, and I want you to be confident that what you're learning is correct. So to help with that confidence, make sure you do check out the previous video at least that goes over chapter 9 of the codebook. It goes over some really good pointers that you're going to want to know through chapter 9 and then goes over the very important tables. I would also recommend the conduit sizing video in the last video because we go over some tables in there that are not mentioned in the chapter 9 video, as that video is supposed to just be a brief video going over the important highlights of chapter 9. Okay, and to sum up the point of why I did it that way, it was to show you that if we know the size of our conduit that we're working with, the 0.213 inches squared, and we know the size of the conductor we're working with, we're just going to take the size of the conduit and we're going to divide it by the size of the conductor. That's going to tell us how many times the conductor is going to go into that conduit. And again, we're going to round up if we have over 0.8. Okay, here's the next question. We see we just have the additional second part of this question now. How many number 12 THHN fit in a 3/4 inch EMT that already contains 3 number 10 THHN? Okay, so I'm just going to keep this written here. So we need to know the size of 3 number 10 THHN. We're also going to need to know the size of the number 12 THHN, as well as the 3/4 inch EMT. Okay, so let's get into it. Okay, so first we're going to find the number 10 THHN size. Here in table 5, I see THHN. Number 10 is 0.0211. And of course, this is inches squared. This is in the approximate area where it says inches squared, that vertical section there. And of course, we're going to have 3 of those. So multiplied by 3. Next, we're still looking at the THHN, but now number 12. And we see that is 0.0133 square inches. Then next, we want to find the size for our EMT. We go into table 4 and we look at the 3/4 inch EMT. And again, we're going to have the 0.213, just like the question we had before. Okay, so now we're just going to have to multiply the 0.0211 by 3. That gives us 0.0633. Okay, so now we need to think in context of what this question is telling us. It's telling us this 0.0633 is the size of the 3 number 10 THHN conductors. These are already taking up space in the EMT. We know the size of the EMT, so all we're going to do is take the size of the EMT that we have right now, and we're going to subtract by the size of the 3 10-gauge conductors. That'll let us know how much space we have left. Okay, the 0.213 minus 0.0633 is going to give us 0.1497 square inches. That's going to be the leftover space in this 3/4 inch EMT. Okay, so now we want to know how many number 12s we can fit in the leftover size here. So all we're going to do is take advantage of that lesson taught in the first part of this question. So we're going to get the leftover size 0.1497 square inches, and we're going to divide that by the size of the number 12 THHN, the 0.0133 square inches. Okay, and we'll get the answer 11.2556, and it'll keep repeating. So I'm just going to round it off because it's not over 0.8, and we're going to have 11 conductors as our answer. So that is the final answer to how many number 12 THHN can fit in a 3/4 inch EMT that already contains 3 number 10 THHN. We can fit 11 more number 12 THHN conductors. Next question, how many 1/0 XHHW fit in a 2.5 inch Schedule 40 PVC that already contains 4 4/0 XHHW. Okay, so I'm going to keep that where that is because we're going to need to know the size of all that, as well as the size of the single 1/0 XHHW conductor, as well as the size of the Schedule 40 PVC conduit that is 2.5 inches. Okay, we're going to go into table 5. We're going to look for XHHW, and then we're going to look for 4/0, and we see 0.3197. And again, we have 4 of these, so we're going to have to multiply that by 4. Okay, now we're looking in the same location. We just want 1/0 XHHW now, and we see the number 0.1825 square inches. Of course, in real life, when you actually start to solve for these things, it's going to get a little messy if you're writing inches squared all the time. So I'm just writing the decimal points at this point. And now we're going to be looking at the Schedule 40 PVC 2.5 inch. We're going to look back at table 4. We're going to go back a few pages, and we see the 2.5 inch trade size, which is 1.878 square inches. Okay, so now we know the sizes that we're working with. The first step we're going to want to do here now is multiply the 0.3197 by 4. Okay, so now before I get into the first step here, make sure you have the question memorized or written down because I'm going to have to erase it to make some more room now. Okay, so the first thing we're going to want to do is multiply the 0.3197 by 4. And that will give us the product of 1.2788. I'm just going to write that up here. Okay, so we know the total amount of square inches that 4 XHHWs are going to take up. Now we're just going to have to take the size of the Schedule 40 PVC and subtract this now 1.2788 from that. 1.878 minus 1.2788 is 0.5992. That is the leftover size that we're working with. Now again, we're going to take that leftover size and we're going to divide that by the size of the conductor that we're going to want to fit in. In this case, we have the 1 XHHW at 0.1825 square inches. And that will give us the answer 3.28, and it keeps going. But in fact, this is under 0.8, so we're just going to keep it at the 3 conductors. And there's our final answer for how many more 1 XHHW conductors can you fit in a Schedule 40 PVC that is 2.5-inch trade size that already contains 4 XHHW conductors. And that is 3 1/0 XHHWs will fit. Next question, how many number 12 THHN fit in a 20-inch nipple of 3/4 inch EMT that already contains 3 number 10 THHN. Okay, and if you don't know the rule about nipple fill, as funny as it sounds, go to the beginning of chapter 9, and where it says notes to tables number 4, we see it states that conduit or tubing nipples that do not exceed 24 inches installed between boxes, cabinets, or similar enclosures shall be permitted to be filled with the 60% column, or what it says 60% of their total cross-sectional area. That means we're going to use the 60% column when we're looking here at table 4. Okay, so we're going to want to know the size of the 3 10-gauge THHN conductors, as well as knowing the size for a single number 12 THHN conductor and the 20-inch nipple that is 3/4 inch EMT. I'm going to first look for the number 10 THHN. Here I'm in table 5, I see THHN number 10, and it is 0.0211 square inches. And of course, we have 3 of those, so we're going to multiply that by 3. Next, we want to know the size of the number 12 THHN conductor. Again, table 5, THHN number 12 is 0.0133 square inches. Next, I want to find the size for this 20-inch nipple that is 3/4 inch EMT. Just like before, I'm going to look for the 3/4 inch EMT in table 4. But things are a little different here. We're still in the EMT table, and we're working with a trade size of 3/4 inch. But now we're working with the 60% vertical column. And of course, the square inches there. So we see for 3/4 inch trade size, that is 0.320 square inches. Okay, so now we know the basic sizes for everything. Make sure you have this written down or memorize the concept of it, because I'm going to erase the question now. And now the first thing we're going to want to do is multiply the 0.0211 by 3. That's going to give us 0.0633 square inches. And now we know the total size that the 3 number 10 THHN conductors are taking up. Again, now we're just going to take the size of the conduit that we're working with. In this case, we're working with the 20-inch nipple. And since it's less than 24 inches, we used that 60% column, giving us the 0.320 square inches. We're going to take the 0.320 square inches and subtract it by the 0.0633. Okay, that's going to give us 0.2567 square inches. That's going to be the total leftover space that we have to work with. Now we want to know how many more number 12 THHN conductors can we fit in there, and we see that they're sized at 0.0133 square inches. Just like before, now we're just going to take the leftover number, the 0.2567, and divide it by the 0.0133. That'll give us the answer 19.300, and it's going to keep going. So we're going to round that off at 19 conductors, since that's not over 0.8. So we can fit 19 additional number 12 THHN conductors in a 20-inch nipple of 3/4 inch EMT when we already have 3 number 10 THHN conductors in there. Okay, next question. How many more 2/0 fit in a 3-inch Schedule 80 PVC that already contains 5 1/0 THHN. Okay, so we're going to need to know the size of 5 1/0 THHN conductors, a single 2/0 THHN conductor, and a 3-inch Schedule 80 PVC conduit. First, let's look at the 1/0 THHN conductor. Here we are in Chapter 9, Table 5. We see THHN, and we see a 1/0 is sized at 0.1855 square inches. But in fact, we have 5 of those, so we're going to have to multiply that by 5. Next, we have a single 2/0 THHN. So again, THHN, we look at 2/0 and we see 0.2223. Okay, now that just leaves us with the size of the 3-inch Schedule 80 PVC. We're going to go back a page or two. In fact, this one is just back a page, and we're going to see the Schedule 80 PVC. Trade size 3 is going to be 2.577 square inches. Now we have the size of the conduit that we're working with. Again, I'm going to erase the question now. Okay, and the first thing we're going to have to do is take the 5 1/0 THHN conductors, the 0.1855 times 5, and get the product of that. That's going to give us 0.9275 square inches. And now we're going to take the size of our conduit and subtract that by the conductors that are already filling up the space. So we're going to have the 2.577 subtracted by 0.9275. That's going to give us 1.6495 square inches of leftover space. And now we just need to know how many more 2/0 THHN conductors can we fit in there. We already know the size of a single one of those conductors. So we're going to take our leftover space and we're going to divide that by the size of the conductor that we want to fit in there. This will tell us the number of how many of those conductors we can fit in that leftover room. So we're going to take 1.6495 and divide that by 0.2223. That's going to give us 7.42. It's going to keep going. And of course, that is not over 0.8, so we're not going to round up. And now we have our final answer of 7. So we can fit 7 additional 2/0 THHN conductors in a 3-inch Schedule 80 PVC conduit that already contains 5 1/0 THHN conductors. Okay, next question. How many more number 10 THWN2 fit in a 3/4 inch Schedule 80 PVC that already contains 3 number 12 THWN2. Okay, so we're going to want to know the size for the 3 number 12 THWN2, the single number 10 THWN conductor, and the Schedule 80 PVC 3/4 inch conduit. I'm going to first look at the number 12 THWN2 here in Table 5. Looking at THWN2, number 12 looks like it is 0.0133 square inches. And remember, we have 3 of those, so we're going to multiply that by 3. Now we're looking back at THWN2, 10 gauge, and we see 0.0211 square inches. Next, we just want to find the size of the Schedule 80 PVC 3/4 inch. And don't get mistaken with this column here, because you see a blank spot for the 3/8 inch. So you don't have the 3/8 inch trade size. You do have a 1/2 inch, and then you have the 3/4 inch. So we have 0.164 square inches. Okay, now I'm going to erase the question. Now we're just going to want to know the size of these 3 number 12 THWN2 conductors. Okay, now we're going to take the 0.0133 and multiply that by 3. We're going to get 0.0399. Now we have the total amount of square inches that 3 number 12 THWN2 conductors take up. Now we're going to take the size of the conduit we're working with, the 0.164, and we're going to subtract the 0.0399 from that. That is going to give us 0.1241 square inches. That's going to be the leftover available room now that is in the conduit from the subtracted 3 number 12 conductors. Now we want to find out how many more number 10 THWN2 conductors will fit in here. That was my bad for not writing 2 here. It's getting a little late. Sorry about that. Okay, but now we're just going to take our leftover room that we have in the conduit, and we're going to divide that by the size of the conductor that we're going to want to fit in there. Again, that's going to tell us the number of those conductors that we can fit in there. And we see 0.1241 over 0.0211 gives us 5.881. And we see that here we actually are over the 0.8. So we are going to round up. So instead of having 5.88 conductors, we're actually going to consider this to be able to have 6 of these conductors as our final answer. So now we know that we can fit 6 additional number 10 THWN2 conductors in a Schedule 80 PVC conduit that already contains 3 number 12 THWN conductors. Okay, next and final question. We want to find the total area in square inches for a piece of 1 inch FMC. We're going to go over here to table 4. We're going to find the FMC table. Of course, we're going to look at the 1 inch trade size. We're going to note that is 4 from the top down. And then instead of going over 2 wires, 60%, 1 wire, 2 wires, or any of those, we're going to go all the way to the right where it says total area 100%. So they might ask you a question like this, the total area in square inches. And here we're going to use that column. So, okay, we're going to go 4 down from the top and we see the number 0.817 square inches. So we're used to using that 40% over 2 wires column. But here we see we're not using that. And we have our final answer, 0.817 square inches is the total area for this piece of 1 inch FMC conduit. And that's it for this video on conduit fill. If you have any questions, leave those in the comments. If you like the video, give it a thumbs up and be sure to subscribe to see more videos. I have a good amount of videos already posted, some really good fundamental topics like how to rearrange the subject of a formula, how to memorize the Ohm's law formulas, and certain foundational topics like that as well. If you want to personally contact me at this email. And until next time, take care, goodbye.